So here we have an example. The luminosity of the sun is 3.85 times 10 to the power of 26 watt, and the distance of the sun from the earth is 1.50 times 10 to the power of 11 meter. The distance to Proxima Centauri, the nearest star to the earth other than the sun, is 4.25 light years from the earth. The luminosity of Proxima Centauri is 5.81 times 10 to the power of 23 watt. Calculate the ratio radiant flux intensity of Proxima Centauri at Earth's location to the radiant flux intensity of the sun at Earth's location. To answer this question, we have to use the equation F equals to L over 4 pi d squared, where L is the luminosity in watt of the source, F is a radiant flux intensity in watt per meter squared at a distance d from the source, d is the distance from the source in meter. Now we have to apply this equation to the sun and Proxima Centauri. For the sun, we write it as F1 equals to L1 over 4 pi d1 squared, where L1 is the luminosity of the sun, which is 3.85 times 10 to the power of 26 watt. d1 is the distance of the earth from the sun, which is equal to 1.50 times 10 to the power of 11 meter. F1 is the radiant flux intensity from the sun at Earth's location. For Proxima Centauri, we have F2 equals to L2 over 4 pi d2 squared, where L2 is the luminosity of Proxima Centauri, which is 5.81 times 10 to the power of 23 watt. d2 is the distance of Proxima Centauri from the earth, which is 4.25 light years. F2 is the radiant flux intensity from Proxima Centauri at Earth's location. If we take F2 and divide it by F1, we have this ratio F2 over F1 equals to L2 over L1 times d1 squared over d2 squared. So what is asked in this question is simply to find this ratio. However, before we substitute, we have to convert the distance d2, which is given in light years, into meters. 1 light year is the distance covered by light in 1 year. This can be calculated as 1 light year equals to 365 times 24 times 3600. So this is the time of 1 year in second, times 3.0 times 10 to the power of 8, which is the speed of light in meter per second. So we are going to have a distance in meter, and this is equal to 9.4608 times 10 to the power of 15 meter. And therefore, we have d2 equals to 4.25 light year, which is equal to 4.25 times 9.4608 times 10 to the power of 15 meter, which gives us d2 equals to 4.021 times 10 to the power of 16 meter. And finally, then we substitute into the equation and we get F2 over F1 as 2.10 times 10 to the power of minus 14.